Independent and dependent events. Independent event is where one event does not affect the other. That would be if I had one dice, I pick it up, roll a number, pick it up again and roll a number. Or if I'm flipping a coin. Whenever I have independent events, I always multiply the two probabilities. A conditional probability is saying the probability of B given that A already happened. This line right here means that it's given that A already happened. We use conditional probabilities when we're talking about dependent events. That's where one affects the other. We still multiply the two probabilities together. This would be in a case if I had a deck of cards and I took out a card, what's the probability my next card would be a jack, given that I already picked a queen? So what would be the probability of rolling a 6 and then rolling another 6? You have to think, is this independent or dependent event? Will the other one affect the other? In this case, it does not, because it's the same dice that I'm picking up, rolling, and then picking it up and rolling again. So the probability of rolling 1 6 would be 1 out of 6. The probability of rolling another 6 after that would be 1 out of 6. So the probability of rolling 2 6s in a row would be 1 out of 36. The probability of flipping a coin 3 times and getting the heads each time. These also are not dependent. These are independent events. So this would be 1/2 times 1/2 times 1/2. Because there's only two outcomes, either heads or tails, and I want to see what's the probability of getting a heads each time. So this would be 1/8. Now let's say I have a bag of 20 apples and 5 oranges. That's a total of 25. I typically write my totals right away so I don't get confused. What's the probability you pull out an apple and then pull out an orange? If I were to write this, this would be the probability of picking an apple times the probability of picking an orange, given that I already picked an apple. So pick an apple would be 20 apples, and my total is 25. I multiply that by, I have a total of 5 oranges, but once I took out an apple, I'm only left with 24 remaining fruit in the bag. I'm going to reduce before I multiply. So this would be 1/6. What's the probability of taking out an orange and then another orange? So again, if I write this, the probability of an orange times the probability of a second orange, given that I already picked one orange. The probability of the first orange would be 5 out of 25. Because there's 5 oranges and there's 25 total fruit. Once I took out that first orange, I'm only left with 4 oranges in my bag. And I also took out a piece of fruit, so I'm left with 24 total. So if I reduce before multiply, this would be 1/30. Then my last question says, the probability of taking out an apple, replacing it, and then pulling out an orange. These two events would be independent because I'm replacing the first apple. So I want to find the probability of apple times the probability of an orange. So my apple would be 5 out of 25. And since I'm replacing, 20 out of 25. And since I'm replacing that apple again, my probability of an orange would be 5 out of 25. And if I reduce these, be equal to 4 out of 25. Two dice are rolled, one red and one blue. Find the probability that the red cube shows a 1 and the sum is less than 4. I'm going to write this out. This would be the probability that red is 1 times the probability that the sum is less than 4 given that red is 1. So if I look at my picture as a reference, the probability that the red is going to be a 1 is going to be 1 out of 6. There's 6 total outcomes, only one of them is 1. Now I'm looking at the sum is less than 4, given that I have a red 1. So I'm only going to be looking at this first row, because I have to only pick where the red cube is 1. So if I'm looking at the sum is 4, that would give me, or sum is less than 4, these two options. So I'm multiplying this by 2 over 6. My total here is still 6 because I'm going to count the different ways that red is 1. So if I reduce this before I multiply, this would be the probability of 1/18. The next question is, the blue cube shows a multiple of 3 and the sum is 8. These are also dependent events. So I'm looking for the probability that blue is a multiple of 3 times the probability that the sum is 8, given that blue is multiple of 3. When I'm talking about just blue is a multiple of 3, there's still 6 different options on my number cube. The only two numbers that are multiple of 3 would be 3 and 6. So there's 2 different outcomes. Now I'm going to multiply that by the probability of sum is 8, given that blue is a multiple of 3. So I'm looking at 2 rows. Out of these 2 rows, I have 12 different outcomes that I could get. There's 6 in this row, and there's 6 in this row. So my total is going to be 12. Looking at those 2 rows, I have to find the sums are 8. I have one sum here, 5 plus 3, and I have another sum here, 2 plus 6. I have 2 answers that could be correct. So that'd be 2 out of 12. So if I reduce before I multiply, this will also be 1/18. So be careful when you're doing dependent events. It does help to write out pictures if you have to. The table shows migration from 1995 to 2000. Find these probabilities. Below I already wrote out my totals. This is the total for this row. Midwest is 5,361, and so forth. The reason I do that is so that it's easier for me while I find the probabilities. Is that the immigrant or emigrant is from the West. So if I'm writing this out, this would be the probability that they're from the West, given that they're an immigrant. In these situations, you always look at your given that statement. My given that statement is that they're an immigrant. So that's my total. This is where I'm looking at on the bottom of my fraction, because I already know that they're an immigrant. And then I want to find the probability that they're the West and they're immigrant. So if I look in my rows, that's going to be 2,654. So this would be my answer. So you should always try to write out your probability statement first. B. Someone selected is from the South region is an immigrant. So if I'm writing this out, I'm going to write the probability that the an immigrant given that they're from the South region. So my given that statement is from the South. Well, I already add up my totals from the South. It's 8,285. And then I want to find where they're from the South and an immigrant, which would be 5,042. So this would be my final answer. Now my next statement says, someone selected is an immigrant and from the Midwest. My first two problems that I did, pay attention to where the word is comes in the sentence. The is in between the two topics we're talking about for both A and B. For C, the is in front of the two topics. So it's saying that someone randomly selected is an immigrant and from the Midwest. It's asking us no given that statement. It just wants to find out the probability that it's an immigrant and Midwest. So I take my total number out of all of the people, which is 23,311. And I'm going to be looking in the box immigrant Midwest. My immigrant Midwest is 2,951. So this would be my answer. Again, you should always write your probability statement before you attempt these problems. Homework's on page 815, 2 through 22.